Welcome to a lesson on perimeter. Here at the top, we have the definition. The perimeter for us will be the distance around a shape. Okay, we're going to talk about two-dimensional shapes, actually. So let me add that to my definition, or the sum of all the edges of a two-dimensional figure. On the left, we have a triangle. If we just add up the distances around the edges, we have 3 miles plus 6 miles plus 6 miles, and 3 plus 6 will be 15. Be sure to attach the units miles to that, all right? That would be a rather large real-life example that most likely is a wedge, a triangular shape of land, because those are very, very long distances. The figure on the right is another example that we'll be looking at later on in this unit, and it has something special going on as well. Okay, first of all, this is a much smaller figure. It's measured in inches, but as we talk about the perimeter, the distance on the outside, we'll notice we have 7 plus 6 plus 5 plus 10 plus 15 plus I don't know. Okay, so if we have some distances that are unknown, that doesn't mean we ignore those. We have to first figure out what those distances are and then measure all of the, add up all of the sides after that. So in this particular case, you might be able to tell, but you'll see in a future page that you could develop some sort of right triangle here and use the Pythagorean theorem to figure out the missing distance. So if there is a missing distance, it must be solved for before you find the perimeter. In future modules, not in this module, we'll be considering curved perimeters as well. So let me give you one example. If you have a hexagon, you have 6 sides, an octagon, 8 sides, a decagon, 10 sides. But as you think about infinitely many sides, we're going to eventually talk about the circle. That's a pretty lame circle I drew, but imagine that you have a curved perimeter. And how do we calculate those? Those will be coming up later as well.